Hey friends, welcome to kodEdge. In this session, we will see how to set up and configure alert rules and alert manager to trigger alerts on the notification channels. And here we will be using Slack for notification. So these are the topics we are going to see in this session. First, we will set up Prometheus and Grafana in the Kubernetes cluster. For the Kubernetes cluster, I am using Minikube. After that, we will create a simple sample Springboot microservice, and Prometheus will scrap the metrics from this application for monitoring purposes. Then we will understand and set up Prometheus rule and alert manager configuration. And to get the notification, we will set up Slack channel and we will use its webhook URL in the alert manager configuration. Then we will monitor alerts in the Prometheus WebUI, and this is how the alerts look like in the Prometheus WebUI. After that, we will also see how to create alerts in the Grafana, and this is how alerts looks like in the Grafana dashboard, and this is how we get the notification in the Slack channel. And at the end, we will see some troubleshooting points. So I have already explained Prometheus architecture and different types of custom metrics, and also demonstrated how to create and monitor these metrics in the first part. In the second part, I have demonstrated how to monitor the Kubernetes cluster and the Springboot service, which is deployed in the cluster using Prometheus and the Grafana. So if you are interested in that, please watch this video. I have attached its link in the video description. So these are the prerequisites required for this hands-on. So you should have Docker installed on your machine for Dockerizing the application. Then Minikube is required to create the Kubernetes cluster. Then Helm is required to install the Helm chart. kubectl is required for running the Kubernetes commands. And you can use your favorite IDE and the JDK version. And the last, which is not listed here, that will be your Slack account. So here we are going to use Helm chart for deploying the Prometheus and Grafana, and Helm chart name is Kube Prometheus stack. So just to give you small recap from the previous video, in the previous video we saw that these are the CRDs created by the Helm chart, and out of this CRDs, this Prometheus monitoring CRD we need to see for a service discovery label. Then we created service monitor configuration, in which we use the same label that was mentioned in the CRD like this. Then we did mapping for our Springboot application service. In the service monitor selector section, we use our Springboot application service label like this. Then we also map the port name and job label like this. And due to this configuration, Prometheus was able to discover our Springboot service for scraping the metrics. Okay, so this was what we already saw in the part 2 video. Now we will add configuration for Prometheus rule and the alert manager. But before that, let's set up Prometheus and Grafana in the cluster. Then we will quickly create a Springboot project and deploy it into the Kubernetes cluster. So we are going to use Helm chart for installing Prometheus and Grafana on our machine. So let's search for the Helm chart, that is Kube Prometheus stack. So let's go into the GitHub repository. And here we will find the information for installing the Prometheus and Grafana on our local system. So we are going to deploy this configuration into the Kubernetes cluster. So before running this command, make sure that you have started Docker on your machine. So on my machine, I have already started Docker, and let's start the Minikube as well for creating a Kubernetes cluster. So let me open the terminal, and command will be minikube start -- driver equal to Docker. Okay, so our Kubernetes cluster is created. So let's copy this command from the GitHub repository. So let's copy this command and run it into the terminal. Okay, now let's run the next command to install the Helm chart. So command will be Helm install, then your release name. So you can give any name to your release name, and then this chart name. So let me open the terminal. So command will be Helm install, and release name I am giving as a Prometheus, and your actual chart name. Okay, so let's run this command. So it will take some time to install the Helm chart. So chart is installed successfully. So let me clear it. And if you want to see what is getting installed, let's run the command kubectl get all. Okay, so these are the components getting initialized. So let's wait for some time. Okay, so all the components are ready now. So if you want to see the Prometheus WebUI and the Grafana, so let's run command kubectl get services, and first we will see the UI for the Grafana. So let's copy the service name, and command will be kubectl port - forward, then your services / service name and port. So port will be 80. Okay, so let's queue port 80 and run this command. Okay, so it is giving as a permission issue, so I am running this command with the sudo user. Okay, so let's see the UI in the browser. So URL will be localhost:80. Okay, so username will be admin and password will be prom-operator. Okay, so this will be a password. So I have already explained how to get this password in the part 2 video. So let's log in. Okay, so we have successfully logged in into the Grafana UI. Okay, now let's see the UI for the Prometheus as well. So let me open the terminal and let's open the new terminal window. And here we will copy the service name for the Prometheus. So this is a service for the Prometheus WebUI. So let's run the port forwarding command. Command will be kubectl port -forward, then services, then service name. Okay, and port will be, let's go into the services section, and port is this one. Okay, 9090. So let's queue this port. Let's run this command. So URL will be localhost:9090. Okay, so this will be your Prometheus web UI. So we have successfully deployed Prometheus and Grafana into the Kubernetes cluster. Now next what we will do, we will create a simple Springboot microservice using Spring initializer and deploy it into the Kubernetes cluster. So here I am giving name as a Spring Monitoring Alert Kube. Same name I am giving into artifact as well. So build system I am using as a Gradle 1. Then JDK version I am using 17. So let's add dependency in the microservice. So first dependency for the REST controller. So that will be Spring Web. Okay. Next dependency we will add for the actuator. Okay. So this will add dependency for the actuator. And because of this dependency, our application will send metrics to the Prometheus. Next dependency we will add for the Prometheus. So this will add dependency for the micrometer in our application. Let's click on the generate and our project is generated. So let me open this project into the IntelliJ. Okay, so our project is initialized. So let's go into the build.gradle file. And here we just remove this version. So we are not using versioning for our jar. So these are the dependencies added by the Spring initializer. So now what we will do first, we will create a REST controller. So let me create a class for that. So I'm creating class in the default package. So class name will be that I am giving as a test controller. Let's add annotation for the REST. Annotation will be @REST controller. And here we will add the APIs for calling our application. So first API I am adding as a get mapping and URL will be /data, and method name I am giving as a public string get data. Okay, and here I am returning some dummy string. So string will be message from Kubernetes or K8. Then I am creating one more API for throwing the exception from our application, because we want to create alerts. So alerts will get triggered based on the error from our application. For that purpose, I am creating one more API and that will throw exception from our application. So for that also I am using get mapping and URL will be /for_error. Okay, so you can give any name as per your requirement. And next I am creating method for that. So method name I am giving as a get error. Then I'm throwing exception from here. So throw new runtime exception. And let's give some parameter. Okay. So this API will return the some dummy string from the Kubernetes, and this API will throw the exception, and based on this error we are going to create alerts in the Prometheus WebUI. Now next what we will do, we will add the configuration for the actuator. Okay, so we want to send metrics from our application to the Prometheus. For that purpose we require to provide some configuration. So let me rename this file to the application YAML file. Okay, so this is a property file. I am making it to the .yaml file, and let's open this file and let's add the configuration for the actuator. So here I am providing the port name. So this will be optional part. So by default our application exposes on the port 8080, but if you want to change the port, you can change from here. Then this is also an optional part. So here I am providing name for our application. If you don't want to provide this configuration, you can give application name directly here in this tag. Okay, then this is a configuration for the actuator. So here I am exposing two endpoints, that is health and Prometheus. So on these endpoints our application is going to expose our application metrics, and Prometheus will get the metrics from these two APIs. Okay, then I am providing the application name here. Next what we will do, we will dockerize our application. For that purpose let's create a file. So file name will be docker file, and this is the configuration for Docker. So here I am using a parent image as a OpenJDK 17. Then I am exposing our application on port 8080. Then I am copying jar into the Docker. So our jar is going to create into the libs folder, and libs folder will be in the build folder. Then this is a command to execute our jar. Now next we will add the configuration for the Kubernetes to deploy this microservice in the Kubernetes cluster. So let me open the terminal. So let's add the new terminal and let's cd into our project. Okay, so this is our project directory. So let's build our project first. Okay, so our project build is successful. So if you go into the IntelliJ, into build folder, in the libs folder, you can see jar is created. Now what we'll do, we are going to use Helm chart for our application as well. The command will be helm create, and here you can give the folder name. So Helm chart will create a Kubernetes configuration in this YT chart folder. Okay, so you can give any name to your folder. Let's execute this command. Okay, so it has created the chart. So if you go into the IntelliJ, you can see it has created the new folder, that is YT chart, and in this folder it has created the Kubernetes configuration. So let's change the configuration as per our requirement. So let's go into the values.yaml file. So let's change the image name. So image name I am going to give that we are given for the jar. Okay, so here it will come the image name, tag will be latest one. Then next configuration we have to change in the service. Okay, so type will be node port and port will be 8080. And let's go into the deployments.yaml file. So let me go into templates, click on this deployment.yaml file, and let's comment this readiness prop and the liveness prop. Okay, so we are not going to use this configuration, so let's comment it out. Okay, so our application deployment is ready. Now next what we will do, we will add the configuration for the service monitor. So let's create a new file. So file name will be service-monitor.yaml, and configuration will be like this. Okay, so I have already explained this configuration in the part 2 video, so I will skip this explanation in this video. Next configuration I need to change in the values.yaml file. So here I am adding few configuration for the labeling purpose. Okay, and same label we are going to use in the application service.yaml file. So let me copy configuration for that. So let's open the service.yaml file, and here we are going to use the same label. Okay, so here what I am doing, read it from the values.yaml file from the service section, and from within the service section read it from the service label. Okay, so same like from the values.yaml file, from the service section, from the service label section, same for the job name as well. And the same label you need to provide into the service monitor match label section. Okay, and this is what we seen in the part 2 video. Now let's deploy this configuration in the Kubernetes cluster. So let me open the terminal. So first what we will do, let's run one minikube command, that is eval $minikube docker -env. So this command is required to get the image from our local machine, right? So let's run this command and let's build the image for our application. So command will be docker build -t, and name I am giving as a this one that we are using the values.yaml file. So we have given this name, so we are going to use the same name in the terminal, and at the end add dot. Okay, so this is going to create image in the minikube docker environment because of this command. Otherwise it will pull the image from the docker hub, so it will take some time to build the image. So let's wait for some time. Okay, so our image is created. Now if you want to verify the image, you can run command minikube image ls. Let me change the spelling. Okay, so here you can see the image is created for our application, that is Spring Monitoring Alert Kube. Okay, now next what we will do, we will deploy our Kubernetes configuration, that is our application Kubernetes configuration in the Kubernetes cluster. So command will be helm install, then your chart name. So you can give any name to your chart. So I am giving as a my chart. Then your configuration folders, that is YT chart. So let's run this command. Okay, so our helm chart is created with the name my chart. So if you want to see the number of chart that is installed on your Kubernetes cluster, you can run command helm ls. Okay, so we can see we have first installed the Prometheus, then we install the my chart. So let's run next command, that is kubectl get all. So here you can see this is our service for our application. Then this is pod for our application which is running. Now what we will do next, we will test our application. So let me clear it and let's run command kubectl get services. Let's copy our service name that is for our application, and let's run command kubectl port -forward, then your services / service name, and port will be 8080. Okay, so let me open the browser now and let's call the URL. So API URL will be localhost :8080 / data. Okay, so we are getting message from our application, and let's run other URL as well to throw exception from our application. So URL was for error. Okay, so here we are getting the status as a 500. Okay, so we are ready with our application. Now next we will set up the rule configuration and the alert manager configuration. So this is how the configuration looks like for the Prometheus rule. So Prometheus rule configuration specifies the condition under which alerts should get triggered based on the metrics collected by the Prometheus. And now let's understand all the components in this configuration. So first is a kind, which is specifies the type of resource. So in this case, it will be Prometheus rule. Then next is a group. So basically it's an array of rule groups. Each groups can contain multiple alert. Then this is the name of the rule group. So I am giving it as a Springboot microservice error. Next is a rules. So this is also an array of rules within this group. Then this is the name of alert. So I am giving it as a high error rate. Next is the expression. So this is a Prometheus expression that defines the condition for triggering the alert. So here I have given the hypothetical condition. In the hands-on, we will see the actual condition. So next is a for. So this is a duration for which the expression must be true for alert to be considered firing. And I am setting it for a 1 minute. Next is a label. So this is a label associated with the alerts. So I am giving the severity label as a critical. And next is an annotation. So this is additional metadata or descriptive information for the alert. So for this as well, just like we saw in the service monitor configuration, we will require to check the label in the CRD, and that is in the same CRD, that is Prometheus monitoring CRD. And we need to check the label under the rule selector configuration, and we have to use the same label in our Prometheus configuration like this. So let's add this configuration in our project. So here in the IntelliJ, we'll create a new folder. So let me collapse it. And here we are going to create a new folder. Folder name will be alert-config. And in this folder, we are going to add configuration for the Prometheus rule. So let me create a new file. File name will be Prometheus-rule.yaml. And this is the configuration for the Prometheus rule, which I already explained. So here I am using the label that is release:/Prometheus. Now let me open the terminal. Let's open the new terminal. Let's run command kubectl get crds. Okay, so let's copy this name, that is Prometheus monitoring, and let's run command kubectl get then your crd name -o yaml. And here you can see there will be rule selector, and you can see in the rule selector section label is release:/Prometheus. So same label we are using in the Prometheus rule configuration. So let's understand this expression which I told I will explain in the hands-on. So let me take this section in the next line. So here first what I am doing here, I am getting the HTTP request with the status code as a 500 within the 1 minute time period. Then I am calculating the rate of HTTP request with the 500 status code. Then I am dividing this rate with the total number of HTTP requests within that 1 minute time period. Then I am calculating the percentage. And at the end, what I am doing, what is the meaning of this whole expression? If this rate is greater than 1%, in that case, this Prometheus alert will get triggered. So let's apply this configuration into Kubernetes cluster. So let me open the terminal. So let me clear it. So command will be kubectl apply -f, then your folder name, that is alert config, and then your file name. So file name was Prometheus-rule. Okay, and let's execute this command. So let me change this syntax. Because of this syntax, it was giving the exception. So let's execute this command again. Okay, so our rule is created. Now if you want to see if this rule is created successfully, let's run command. So command will be kubectl get Prometheus rule. And these are the some predefined rules. And here you can see the rules that we have created just now. Okay, another way to verify if the rule is created or not, you can verify from the Prometheus WebUI as well. So let me go into the browser, and this is our Prometheus WebUI. Just refresh this page and just click on this alerts menu, and here you can find the alert for our application. So you can see this is a alert we have created. So if you go into the IntelliJ, we have given the alert name with the high error rate, right? So this is the same alert we can see here in the Prometheus WebUI. Okay, and you can search that alert using this search bar as well, right? So this is the alert we have created. Now next what we will do, we will add the configuration for the alert manager to trigger this alert, right? So let's understand the alert manager configuration using slides. So this is how the alert manager configuration looks like. So this configuration will allow you to specify how alerts are routed and notifies the external system, like Slack in our case. So let's break down each components and understand all the components from this configuration. So first is a kind component. Basically, it specifies the type of resource, so that will be alert manager config. Then next is a root section. So basically it used to define how alerts are routed and processed. So it provides a set of rules that specifies how alerts are grouped, processed, and forwarded to the specific receivers. Next field is a group by. So group by field is an array of label names by which alerts should get grouped. So in this example, alerts are grouped by the alert name label. And grouping alerts will help you in aggregating the similar alerts together. So it makes easier to manage and reduce the redundant notification. Next field is a group wait. So this field specifies the time to wait before dispatching a group of alerts to the receivers. Next is a group interval. So this field defines the time interval between sending a batch of alerts to a receivers, and it determines how often the group of alerts should be sent to the specific receivers. Next field is a repeat interval. So this field specifies how long to wait before sending a notification again if it has already been sent successfully for an alert. And normally repeat interval should not be less than group interval. Next field is a continue. So if this continue field is a true, in that case it allow alert manager to continue processing additional routes even after match has been found. And if this continue field is false, in that case it will stop processing the routes after the first match. So here we define the set of rules. So each route can have its own set of conditions and the configuration. So here you can define the matches to match certain conditions like alert name and the service name. Next field is a receiver. So receiver field specifies the default receiver. So in case there is no specific route match, then the alert will be sent to this default receiver. So this is a receiver section. So here we define the configuration for different notification channels or receivers. And I have configured the Slack channel here. So if you see in the API URL section, name and the key will come from the secret. And we will see that secret in the hands-on. So same like alert manager configuration, here as well we will require to see the selector in the CRD. And here we will see that in the alert manager CRD. So if you see in the description of the alert manager CRD, its alert manager config selector and alert manager config match strategy are empty. And here we are required to add label to use in alert manager configuration. For that, we will copy the values.yaml of this Prometheus Helm chart in our local system. Then we will add label in this configuration. I will use the same label like we use in other configuration, that is release:Prometheus. But you can give any label here, okay? And the same way you can give the customized label for service monitor and Prometheus rule as well that we saw earlier. And type will be none for the alert manager config matcher strategy. Now the same label we will use in the alert manager configuration like this. So let's add this configuration in our project. So before adding configuration for the alert manager, we require to add certain configuration into the values.yaml file. So let me open the terminal. Let's clear it. And here if you run the command kubectl get crds, and here if you see this alert manager, so let me see the configuration for this kubectl get, then your crd name -o YAML, and here if you see in this section alert manager config selector is empty. Okay, so we have to change this configuration. We require to add certain labels. Okay, for that purpose what we will do, we will copy the helm chart values.yaml file into our local system. So command will be helm show values, and let's copy the chart name. So chart name we can copy from here. So this is a chart name, right? So just copy this name and let's use it into the command. Okay, so this will return the values.yaml file configuration, and we need to copy this configuration on our local machine. So I am using the same folder, that is alert-config, and I am copying this configuration into values.yaml file. Okay, so file is downloaded into our local machine. So let me open the IntelliJ. And if you see, values.yaml file is created. And here you will find all the configuration related to the Prometheus. So you can customize any configuration from the values.yaml file. So here let's search for the alert manager config selector. Okay, so they have also provided the example how to add the labels. So let's remove these brackets, and here we will add the label, that is release:Prometheus. Okay, so this was the first change. Second change we have to do for the alert manager config matcher strategy. So let's search for that. Okay, so here as well they have provided the example how to add the configuration. So let me remove this, and here we will add the type equal to or type :none. Okay, so this is the configuration required for the alert manager. Now let's add the new file into this alert-config. So let me add the new file. File name will be alert-config.yaml. Okay, so you can give any name to your configuration, and you need to use the same name into the kubectl apply command. So I am giving name as alert-config.yaml, and this will be the configuration for it. So here I am creating a secret to store our webhook URL for our Slack channel. And next configuration is for the alert manager configuration. And this configuration I have already explained in the slides. And this is the section for the Slack configuration. And here I am using the Slack webhook. So if you search the Slack webhook, this is coming from the secret name. And this is a key for the secret. Okay, so if you search this name, you can find here, right? So this is the same name I am using in the API URL section. And this is how you define the title and text for your alert that you will see in the Slack channel. So this will return the name of your alert, and this will be the summary and description of your alert that you have given into the Prometheus rule section. So our alert manager configuration is also ready. Now next what we will do, we will get the webhook URL for our Slack channel. So let me open the browser. So I have already created a Slack account, so it is very easy to follow step to create the account. So first create a Slack account, and whatever the name you give it to the workspace, that will appear here. So let's create a new channel for our alert. So click on these channels, click on this create and create channel. So name I'm giving for the channel as a YT alert. Let's click on the next. So it will be a public channel. So let's create it. So skip for now. Okay, so our YT alert channel is created. Now to get the URL, so click on this workspace name here, and let's go into this setting and administration. Click on the manage app, and here click on the build, create a app. So click on the from sketch, and here you need to give the name for your app. So I'm giving as a YT demo -app. Okay, so you can give any name to your app. Okay, and let's select the workspace. So workspace name is kodEdge. Click on the create app, and here you will find the option for the incoming webhook. So click on this option. Now click on this activate incoming webhook, and here you will find the option to create the webhook. So click on this add new webhook to workspace. So select the channel for which you want to create the webhook. So we have created the channel YT alert for the alerts, right? So click on this channel, click on the allow. So here you will find the webhook URL. So copy this URL, and let's copy this URL into our configuration. So let's add that URL here. Okay, so this will be our webhook URL. Next, we need to provide the channel name. So in the Slack configuration, you can see there is a channel section. Let's change this name to YT alert. Okay, so this is the channel that we have created into the Slacks. Now our configuration is fully ready. Now what we will do, we will first deploy this values.yaml configuration into Kubernetes. After that, we will deploy this configuration. So let me open the terminal. So command to deploy values.yaml file, command will be helm upgrade, then your release name, so that was Prometheus, and then your actual chart name. So this was a chart name, so let me copy this, and then your file name. So file name was in the alert config folder, and file name is values.yaml file. So let's execute this command. Okay, so it has applied the configuration in the cluster. So if you want to verify this, let's run command kubectl get crd, and let's copy this alert manager crd name, and let's run command kubectl get then this name -o YAML. So let me correct the spelling. And here if you see in the Alert Manager configuration selector section, it has added the label name. Same for the matching strategy as well. Okay, so our configuration is applied successfully. Now let's add configuration for the Alert Manager. So command will be kubectl apply -f, then our folder name and the file name. Okay, so this was the file we have created for the Alert Manager configuration. So let's execute this command. Okay, so it has deployed the configuration successfully. Now let's verify our secrets. So the command will be kubectl get secrets, and here you can see this is the secret that we have created. So let's run command kubectl get secret, then your secret name -o YAML, and here you can see the secret that you have created. So here this is the name of your secret, and this is your Slack webhook URL. Okay, so let me clear it. Now to see the UI for the Alert Manager, let's get the service name for the Alert Manager. So command will be kubectl get services. Let's copy service name for the Alert Manager, and let's run command for the port forwarding. So command will be kubectl port-forward services/service name, and port will be, so for the Alert Manager port is 9093. So let's use this port, and let's see the UI for the Alert Manager. So let me open the browser, and URL will be localhost colon 9093. Okay, so this is the UI for the Alert Manager. Now if you go into the status, and here you will find the configuration for the Alert Manager. Okay, now if you see, this is our receiver, that is Slack notification. So this is the name we have given for the receiver, right? Then if you see, this is the configuration for the Slack configuration. Okay, now next, if you see in the alert section, so these are the alerts already triggered or in the firing state. Now if you go into the Slack channel, you can see some of the alerts getting triggered, and we are getting the notification for the same alerts. So these are the same alerts that we can see in the alert section. Now next, what we will do, we will test our alert. So we have added alert with the high error rate. If you see in the Prometheus WebUI, so this is the alert we have added, right? So we will test this alert, and we will see if we get the notification for the same in the Slack channel. Okay, now to test this alert rule, what we are going to do, we are going to call this error URL from our application as well as data URL from our application. Okay, so make sure that if you're calling this data URL for one time, then call this error URL for the 5 times, for example. Okay, so let's call this URL. Keep doing this hard work for 1 minute. Make sure that you should call this error API more than this data URL. And if you see here, it is in the pending state. So let's keep doing this hard work for 1 minute. And if you see, our alert is in the firing state. And if you go into the Slack channel, you can see we have received the notification for the alert that we have added here, right? So high error rate in the Spring application, and this is description that we have added into the configuration, and this is the value that we are getting from the error rate. So 62.63 is the error rate. Okay, now next what we will do, we will add the alert into the Grafana dashboard. So let's go into the Grafana, let's refresh this, and let's create a new dashboard. So if you go into the connection setting in the data sources, you can see data source is added by the Helm chart, that is Prometheus. So our Grafana is already connected with the Prometheus server. So let's go into the home, and let's click on the dashboard. So here we are going to create a new chart. So click on the new dashboard, and here click on the add visualization. Let's select the default data source, that is a Prometheus. And here I am creating a time series chat. So here we are going to add some queries to get the chat. So let's search for the HTTP _server _request seconds count. Okay, so let's select this matrix and let's run the query. Okay, so these are the metrics that we are getting from the Prometheus. Okay, now we will filter this matrix further. So let's add the label. So I am adding a label as a job, equal to job name will be Spring microservice job. And you can see query is created here. So as you add a new filter here, query will change automatically. So let's add one more filter. So here I am adding filter for the status. So status equal to 500. Okay, you can see query is changed now, and let's execute this query. Okay, so you can see chat for the error request. So what this chat will show? This chat will show number of requests with the status code as a 500. Now next what we will do, we will add function to this matrix query. You can see it already giving the hint. So let's click on the add rate. Let's select the interval as a 1 minute. Okay, so our query is changed now. You can see rate function is applied to our query with the 1 minute time period. Okay, so our chart is created now. Let's save this chart. So let's click on the save. So you can give any title here. So I'm giving as a Spring dashboard. And let's save this. Okay, so you can give the title for your chat as well. So let's click on this 3 dots, click on the edit. So here you can give the name for your panel. So I'm giving as a YT chat error. Okay, so let's save this chart and let's apply. And here you can see the chart name. Now next what we will do, we will add the alert in this chart. But before that, we require to do Slack configuration in the Grafana. So first option is you can use the same configuration that you have added into the Prometheus AlertManager configuration. Otherwise, you can also create the second configuration in the Grafana as well. So I will show the both the option. First, we will see the creating configuration manually. So let's go into the menu option here and let's expand this alerting section and click on this contact points. So here you can see the option for the adding new contact point. So click on this add contact point option. And here let's give the name as a Slack config YT. And here search for the Slack. And here you need to provide the webhook URL. So let's copy the webhook URL from here. And let's click on this test option here. So let's click on the send test notification. And if you go into the channel, you can see we have received the test alert from the Grafana. So let's save this configuration. So if you see here, it is showing as a unused. Okay, so by default, this contact point is selected. So let's click on this notification policies option here and click on this 3 dots here in the new nested policy section. Click on the edit and here select the Slack config YT. Okay, and click on the update default policy. And if you go into the contact policy, you will see the health status as a okay, and the default one is changed to unused. Okay, so Slack configuration is ready in the Grafana. So let's go into the dashboard again. So click on the dashboards. And this is the dashboard that we have created. So click on the Spring dashboard and click on this edit chat option. And click on the alert section here. And click on the create alert rule from this panel. And here we are going to configure the query for the alert. So what we will do, we are going to use the same query. So metrics will be HTTP server request, second counts, job will be the same, that is Spring microservice job, status code will be the 500. And here we are going to add one more filter for the URL. Okay, so search for the URI and equal to for error. Okay, so we want to see metrics only for this particular API. Okay, so our query is ready for the alert. Next, what we will do, we will add the condition under which condition we want to trigger this alert. Okay, so let's go into this expression section, and here you will find the condition for the reduce, and here it is taking input as a, so a will be this matrix. Okay, then function will be, we are going to select max, and mode will be strict. Okay, then next will be threshold section, in which input will be this b, and let's give value as a 0.5. Okay, so you can give any value here as per your requirement. For testing purpose, I am giving as a less value, that is 0.5. Now let's go into the next section. So here we need to select the folder. So let's create a new folder, giving name as a YT. So you can give any name as per the requirement. Then select the group. So there is no group available, so I'm creating a new group. So I'm giving as a YT group, and time I am giving as a 1 minute. Let's click on the create. Let's keep the pending period as a 5 minute. Okay, so let's click on this save rule and exit option here. Click on this button. Okay, so rule is created now. Now next what we will do, we will test this alert in the same way that we have tested with the Prometheus WebUI. So let's call the error API multiple times, and keep calling this API at least for the 1 minute. Now you can see alert is in the firing set. So just refresh this chart from here, and you can see the whole chart. And after 5 minutes, we can see in the channel we have received the alert from the Grafana. Now let's go back into the Grafana, and let's close this chart. So next what we will do, we will use the same Slack configuration that we have configured in the Prometheus. So for that purpose, what we can do, just go into here, click on the context points, just click on this choose alert manager option here, and select the alert manager. So this alert manager is coming from the Prometheus. Okay, and here you can see the configuration for the Slack that we have configured in the Prometheus. Now if you want to test this configuration, do the same way we did for the previous chart. Okay, so this is how we have successfully configured the alert manager and the rules configuration into the Prometheus and the Grafana. Now next what we will see some troubleshooting points. So there are chances that this configuration may not work for you in the first go, and if you want to debug, how you are going to debug this configuration. Okay, so for that purpose, what you can do first, let's go into the values.yaml file, and here we are required to add the log level as a debug one. So here you can see log level for the alert manager, right? So change it to the debug. Next you need to apply this configuration. So let me open the terminal. So command will be helm upgrade Prometheus, that is your release name, then this is a chart name, and your file name, that is values.yaml file. Okay, so next what you can do, just get the name of all the pods. Okay, and you can see the logs for the alert manager and the Prometheus. So let me see log for the alert manager first. So command will be kubectl logs -f and the pod name. So here you will get the logs for the alert manager, and if there is any issue in your configuration, you can see that issue in this log section. Okay, now let me close this log, and let's see the logs for the Prometheus. So let me copy the name for the Prometheus pod, and let me clear it. So command will be kubectl logs -f and the pod name, and here you can see the logs for the Prometheus pod. Okay, so this was the first option. Second option is, let's say you have applied the alert manager configuration in the Kubernetes cluster. Okay, and let's say the configuration is not getting updated into this alert manager status section. Okay, so let's say you are not able to see your configuration in this status section. In that case, what you can do, there is one URL provided by the Prometheus. So this is the URL that is provided by the Prometheus, and it will reload the configuration for the alert manager. Okay, so this is the second option. Let's say this also not work for you. So what you can do, you can restart the alert manager pod and the Prometheus pod, and then you just refresh this alert manager status section. Now let's say this option also not works for you. In that case, what you can do, you can do same configuration into the values.yaml file of the Prometheus. So let me open the IntelliJ, and here in the values.yaml file in the alert-config folder, search for group_by. So here you can give the same configuration that we have given into the alert manager configuration. Okay, so if let me open this file side by side. So this is our values.yaml file. Okay, and this is our alert-config.yaml file. So here tags are in the snake case format, and here tags are in the camel case format. So here you can specify the group by, wait interval, repeat interval, and the receiver. Then here you can specify the routes that we have specified here. And here in the receiver section, you can attach this section in the receiver section here. And after that, you can apply this values.yaml file, and you can see the configuration into this status section. Okay. So I'm not demonstrating this configuration in this video. So I will add this configuration into GitHub repository. So you can see this configuration into troubleshooting folder in the GitHub repository, and I will attach the URL of GitHub repository in the video description. So one more thing I forgot to show. So let me open the browser and let's go into this Grafana. So in the Grafana as well, you can see all the alerts or rules that you have created into this Prometheus. So if you go into this menu section, click on the alert rules here, you can see all the rules from the Prometheus as well. So let's search for our rule. So our rule name was high error rate. Okay, so let's search that rule name here. So this was the rule that we have created in the Prometheus, right? So let's expand this, and you can see label is critical. Then this was the expression that we have added into this configuration, right? If you want to see the graph, let's click on this button, that is see graph. And here you can see the chart for your Prometheus rule. Okay, so this is how we have successfully configured the alerts in the Prometheus and Grafana. That's it for this lecture. Thanks for watching the video.